Example 5, identifying a horizontal shift of a toolkit function. Figure 8 represents a transformation of the toolkit function f of x, which is equal to x squared. We want to relate this new function g of x to f of x, and then find a formula for f of x. So if you take a look, here is a parabola. Okay, now normally the parabola is at the origin. Okay, so you can see here that what happened to this? Well, it moved to the right 2 units. So again, the graph is identical to the shape of f of x equals x squared function, but the x values are shifted to the right 2 units. The vertex used to be at 0, 0, but now the vertex is located at 2, 0. And the graph is the basic quadratic function shifted 2 units to the right. So let's take a look at the graph and let's talk about that. Now, the vertex of a parabola is the point at the intersection of the parabola and its line of symmetry. So the vertex can be the absolute minimum, the lowest point of the graph, or the absolute maximum, the highest point of the graph. So this in red is our original function, f of x equals x squared. And so what happened is that this vertex is now moved to the right 2 units. Well, if we shifted the input x 2 units to the right, because x minus 2 equals 0, therefore x would equal plus 2. So g of x would equal f of x minus 2. So then we would say g of x is equal to the input minus 2 units squared. So let's take a look at the function x squared on Desmos just to get a clearer picture of what we're talking about here. So if I have the graph x squared, okay, what does this graph look like? We have a parabola, right? So in our scenario, okay, we had to take the input and subtract 2 to it, and then we squared it, and you can see here that it shifted 2 units to the right, which is what our example has just done. Okay, now let's see what happens if we put in x and then add 2 to that. Well, what do you think is going to happen here? Well, you can see here that when we're adding 2, we're now shifting it to the left 2 units. Okay, so that is a horizontal shift. So x minus 2 is a horizontal shift to the right. Okay, x plus 2 is a horizontal shift to the left. Now, let's take a look at the vertical shift. So if we have x squared and we want to, let's say, add 4 to that, well, you can see here that because we're adding to the output, it's not within the parentheses, we're not adding the input, we're adding to the output, therefore it's shifted up 4 units. Likewise, if we take x squared and now subtract 4 from that, we're subtracting 4 from the output, so we move the graph down 4 units. So the analysis here, to determine whether the shift is plus 2 or negative 2, consider a single reference point on the graph. For a quadratic, looking at the vertex point is convenient. In the original function, f of 0 equals 0. Now in our shifted function, g of 2 is equal to 0. So to obtain the output value of 0 from the function f, we need to decide whether a plus or a minus sign will work to satisfy g of 2, which is equal to f of x minus 2, which was equal to f of 0, which is equal to 0. So for this to work, we will need to subtract 2 units from our input values.